just to give you a little bit of an idea of what happened last time in class. So you were talking about relative frequency histograms. So if you didn't know what that was, that's kind of what we were doing with the asteroids, and when you had to put your data points on those three graphs, we were creating histograms so we could start to look at the different ways that the data kind of, what sort of patterns start to exist. So we're going to be working on seeing those and seeing if we can come up with some ideas of how this all works. So I gave you a set of data here, but I also gave you an e-tool in Canvas if you didn't already look for it. So this is already posted in Canvas for you. So there are 40 runners. They're talking about head circumference. Okay. So if you go into that e-tool, it probably doesn't look like mine right away. And that's because you have to read what it says here. So if you do, it says replace the numbers in the list below with the numbers above. So originally this said 1, 2, 3. So to get it to do this, I just copied this, so Control C. And then I pasted it down here, and then my list shows up. This also calculates the mean, rounded to 2 decimal places. That's what this round means, and the 2 here. And the standard deviation, again, rounded to 2 decimal places. So what do these numbers mean? Well, the mean, we already know. That's our measure of center. It's just our way of saying where is the middle of our data. Now, we've talked about several different types of center over your math career, but mean is the one we're going to use the most frequently for our stats unit. Standard deviation is kind of a measure of distance from the center. So it's saying like how far is the average data point from our center point. So how far are our data points from 53.33? Now, once you've got that all calculated in here, you can kind of take a look at things. So it says that their bin numbers, where was I looking? Here it is, bin width of 1. What that means is at the bottom, our tick marks are just by 1. So 50, 51, 52, 53, 54, 55. Those could be 2s or 3s or 10s depending on your data set. It just depends on what you're looking for. But for us, we care about whole numbers, and they're going to explain why. It says hat size is determined by a whole number portion of a woman's head circumference. For example, a woman with head measuring 55.8 centimeters would need a size 55 hat. According to your histogram, how many women in the sample need a size 52 hat? So first of all, we got to figure out which column are we looking at. So this first column that's blank represents 50 to 51. This next one represents 51 to 52, but that's not what we're looking for. We're looking for 52 to 53 because anybody, they say, with that sort of number, 52.7, 52.1, is going to wear a size 52 hat. So this column is what we're looking at. So it says, according to the histogram, how many women need that size? So it would be 9 because we have 9 people represented in this group. And I can see that because over here off to the side, I can see that that's 10. Then it says, what percent of women in this sample have a hat size of less than 54? Now notice, it says less than, not less than or equal to. So I would only be looking at size 53, 52, 51, etc. So this would be 51, 52, and 53. These 3 columns that I would be adding up in total. So I've got 5, 9, and 17. Add those all together, that should be 31. So I would be able to say 31 out of 40, and I can calculate that as a percentage. So it's 31 out of 40, get a decimal, multiply by 100 to get that percentage. Now, a second option for you when you're dealing with these data sets is to create this relative frequency table. It makes your life a little bit easier because it helps you to recognize where the patterns lie. Now, in this data set, which is pretty simple, it's a little bit easier to see, like, clearly this is the most popular size. Clearly everybody falls in this very specific range. But that's not always going to be the case with some more challenging data. So that's where these charts can come in handy. So to make these numbers, what you're going to do is you're going to take the number of people who fall into that bin. So from 51 to 52, right here, I've got 5 people. So that's where this 5 comes from. And then to get this decimal, I'm going to take the number of people in that bin, 5, divided by our total number of people, which in this case was 40. So 5 divided by 40 gives me 0.125. So to fill out the rest of this table, you would be looking at each of these columns and putting the numbers in this first column. And then the second column comes from taking that number divided by 40. So right here would be 17 divided by 40. Next one would be 54 to 55. I see 4 people. So 4 would go here, and then it would be 4 divided by 40, etc. Now, looking at 73, this is doing kind of the same idea. Now, it asks you to find the mean and standard deviation. I want to be clear, I'm not necessarily testing you on being able to find those numbers. Like, there isn't a target related to can you calculate the standard deviation. So we're going to use some cheat methods, or some shortcuts, I guess, to figure those out. Now, I gave you an e-tool in Canvas that you can look at. So if you go into Canvas in the Chapter 9 e-tools and videos, you can click on that and it'll bring you to this thing. Now, yours probably looks a little bit different than mine. It probably looks like this to start. But what they're showing you is that you can use this to kind of reorganize things to make it a little bit easier. So maybe I want to make a bin width of 2 or 3. So I can change how the numbers are grouped together. Or I can change my scales to make it a little bit easier to see what's going on, because this bin here is pretty tall. And I can start to see how the data is grouped together. Now, it asks you to find this mean and standard deviation, which can be very tedious by hand. So what I would recommend is having one person at your table have this chart open, and one person at your table actually having this chart open. Okay? Because you can calculate the mean and standard deviation using Desmos. So you'll need somebody to read off these numbers, and you can actually replace the numbers in this group that I created for you. So you can just delete all of these out. Or if you're scared to delete them all out, you could always just make a new data set. And then you can put each of your numbers in. I'm typing in random numbers for you. It'll tell me how many numbers should be in my list so that you can check and make sure you have the right number. I believe there should be 40 total because there are 5 by 8. Yep, so 40 total. And then it'll calculate the mean for you right here. So you can type in mean. You can actually do it in any row in a Desmos table. So you'll notice the letters start off italics, but once I finish typing the word mean, it changes to like regular. And then I can ask it to do the mean of my set of data up here. And it'll just calculate it for you. Same with standard deviation. If I start with STDE, it's still in italics, but as soon as I finish the D there, it changes over to regular letters. And then I can ask it to calculate the standard deviation of our data set H. So again, I'm not testing you on being able to do this stuff by hand. We're going to use some kind of cheat methods to help us figure out these things by using Desmos to calculate it for us, because we want to be able to use the numbers, not necessarily just calculate the numbers. So those are the big ideas for today, is being able to look at a histogram and create these relative frequency tables.